So the last one is going to be this. We will have the first lens is going to be a converging lens. F1 is equal to 200 millimeters, which is 20 centimeters. I'm saying millimeters because things are in millimeters there. The second lens is going to be 100 millimeters. So F2, so this is F1. So F2 is going to be 100 millimeters. So that's this one. The distance between them, L, is going to be 100 millimeters, okay? And the object is going to be here. This is the object. The height of the object is going to be 40 millimeters. This is real, for real. The object is going to be 40 millimeters, okay? And then the distance from here to here, S1, is going to be 250 millimeters. So, would the image created by the first lens going to be real or virtual? It's going to be real? Yeah, think about it. It's going to be real because are we within the focal point or after or beyond?
Beyond.
We're beyond. The focal is here, so we're beyond. So it's going to be a real image. It's going to be somewhere, maybe here, maybe there. Now, here's the thing. If the image is here, that would be the object for this first lens, for this second lens. So the object distance is to the left of it. So it's still a positive object distance. But if it overshoots, if the object is here, that's going to be a negative object distance. And it will overshoot in this one. By design. That's why I placed the object kind of closer to the focal point so that it will be a little farther. We want this to happen so that we can see it. So the first thing we're going to do is what? Find the first image. So let's do it. So we get S1 prime is going to be S1 times F1 divided by S1 minus F1, right? Yeah. And then let's multiply S1, F1, so you get 40 times 200, and 40 minus 200, no. What? How am I doing? Why is it 40? 250. Oh yeah, the object, okay. The object distance is 250. Yeah, it seems something goes out. Yeah, so 250, right? 250, and this is 250. Okay, so we're good, right? So 250 minus 200 is 50, right? 250 minus 200 is 50. 200 over 50 is 4. 4 times 250 is 1,000. So that's 1,000 millimeters. 1,000 millimeters. In other words, it's 1 meter. Let's figure out the magnification, M1. M1 is going to be minus S1 over minus S1 prime over S1, and that will be minus 1,000 over 250, right? 1,000 millimeters over 250 millimeters. It's going to be minus 4. Is that true? Okay. It's going to be minus 4. All right, let's figure out where that image is. We said it's going to be 1,000 millimeters. So where is 1,000 millimeters? So it's 1,000 from here, right? So the image is going to be somewhere here. That's where the image is going to be. And it would be 4 times as big, so I can't really draw it that big. So that's too much. But you get what I'm saying, right? That's where this one is. So let me write it here. S1 prime. Okay, so we need now S2. That's the tricky part for this one, S2. So S2, if the object were here, for the object of this lens were to the left of it, that's positive. The problem is that object, this image becomes the object for this lens. It's a negative, so it's negative 900. So let's use our rule. It's L minus S1 prime, right? That would be the easiest way to do it. So L is 100 minus 1000, so that's minus 900 millimeters. In other words, here is S2. That's S2. Okay. Next, we need to figure out where S2 prime is. S2 prime. It would be S2, F2 over S2 minus F2. And that would be okay, that's on purpose so we don't make a sign mistake. S2 is how much? Yeah, minus 900. F2, 100. Minus 900 minus 100, right? So on the denominator I have 1,000, minus 1,000. On the numerator I have minus, I guess 90,000 or 9,000? 90,000. How much is, so minus over minus is plus, so 90,000 over 1,000 is 90? So it would be positive 90 millimeters. So what does it mean, positive 90 millimeters for the image? Okay. It's, what I'm asking is it to the right of this lens or to the left of it? To the right. And a positive image distance will be to the right of the lens, yes. So the image, the final image will be here, 90 millimeters to the right. That's where the image is going to be. And then, its magnification, I don't know. We will need to figure that out. Actually, if this is 100, 90 is going to be somewhere here. Let's figure out the magnification. M2. M2 is going to be minus S2 prime over S2. So that's minus over, what is S2 prime? 90, right? And then S2 itself is how much? 900, I think was that? Negative. Minus 900. And that's a tenth, isn't it? That's 1/10. Positive. Yeah. So therefore the total magnification would be M1 times M2, and that is multiply them. So we get minus 4 times 1/10. So that would be minus 0.4, right? Minus 0.4. So the image at the end is going to be inverted. So we would have our final image would be 0.4. So that's about half the size of this object.
So it doesn't invert for the second one.
This one does not invert again. Yeah. So I'm going to say then y double prime, the height of the image, is going to be m times y. So that's minus 0.4 times 8 centimeters, and that's equal to, is it 8 centimeters? No, 40 millimeters. That was the other progress that were 8 centimeters, right? This one is 40 millimeters. So that would be 16 minus 16 millimeters. Okay? Expect it to be minus 16 millimeters. So now I'm going to, right? This is interesting. This is the first time we get a negative object distance. It's a virtual object creating a real image. Okay, so I am going to, let me pause this, and then I will get closer so that we can video record it, so we can see it. Let it record now. Okay, so I have my object here. This is the light. And I have my first lens. It's a convex lens. It's 200, positive 200 millimeters. And we would like to place it at what? What distance away from the object? Here's our object. 250. So the object is at 0. So 250 millimeters, that's 25 centimeters. So I place my lens here. And we're going to receive a real image. So the image will be here, will be focused here. So we need to move this screen kind of. You will play with this next week in the lab. The second lens, which is the 100, it's positive 100. We're going to place it 100 millimeters to the right of this one. So if this one is at 25, where should I place this next lens?
30.
At 35. 35 is here, right? That's as accurate as I can do. Now the image will be real. It would be inverted. And there are arrows here that tell you. And where do we expect our image to be? It would be to the right of this one. How far? Is it 90 millimeters? Yeah, 90 millimeters. So if this one is at 35, and I need to add 90 millimeters, which is 9 centimeters, so it needs to be at 44, doesn't it? So we will move this screen. For people there, you probably won't be able to see the screen, but so there is an image here that we will see. That if you want to go that way, and you will see it. Would you like to? Yeah, you could just go there, and then you will
Just
you
in
will.
front of the camera.
So yeah, just so that you just see my screen here. As I move the screen until I get a focused image, because I need to figure out where the image is. So I will move my screen. We're cheating because we know approximately where it should be, and it's getting focused right there, right? Doesn't it seem focused?
Yeah.
So whatever we decide is focused, there is a plus or minus a millimeter or so. So this is our image, kind of. I think if we dim the light, I think that's about it.
Yeah.
Now the size of the image is going to be, we're just literally going to measure it. This one is 40 millimeters. And what did we predict? It should be 16 in size and inverted. It's already inverted. I can see the arrow is upside down. Now the size we can measure here. And I see about, I think 18, 17 millimeters. So we're fairly close, okay? So that was that. It wasn't satisfying to actually do it experimentally, double check our work, okay? All right, any questions on this? You will play with this next week. Okay, let me pause this.